Yeah, thank you for again being there to again watch this video for this particular episode. Now, in the previous episode, in the very previous episode, we were able to look at the structure of a compact bone. In case you haven't watched that episode, please make sure you check on the link in the description or in the link up here. In that case, we were able to look at the different ways how we were able to look at the different structure, the whole structure of how a compact bone is. Now, after we have looked at the structure of a compact bone, we need to know how is a compact bone formed. But we are able to also see that the process by which a bone is formed is called ossification. Now, in as far as the compact bone is concerned, a compact bone is formed by a type of ossification known as endochondrial ossification, as I've already told you in the previous episode. Now, the question is, what is endochondrial ossification? We were able to see that endochondrial ossification, the word endo means, the word endo means inside, as far as biology is concerned. Now, chondrio, for those ones who have followed me, who have watched the previous video, you must have realized that I've told you this word chondro has something to do with what? Has something to do with cartilage. Has something to do with cartilage. So in simple terms, when you talk about endochondrial ossification, here we are talking about it's a process by which a bone is formed, but from a cartilage. So endochondrial ossification simply means the process by which a bone, in this case a compact bone, is formed from what? From a cartilage. Or the way you can say a cartilage being turned into a bone. Now, that means, this statement means that we actually, when you consider, for example, a mammal, when a baby is being born, they are born when they are having cartilage. But we are saying as this baby is growing and becoming a mature person, what happens is that the cartilage becomes replaced with what? With bone. That's why when a kid gets an accident when they are still young, they can easily be able to, repairing it becomes very easy. Why? Because most of their skeleton is what? Is cartilage. So the cartilage can easily be remodeled into a bone. But if a person of 80 years gets a fracture, repairing them is not easy. Why? Because at that moment, most of the cartilage has already, actually, not most, but all the cartilage has already been turned into bone. And therefore, when they get a fracture, repairing them becomes very hard. But a kid can easily be repaired because we still have the process of bone development taking place. In fact, by the time you reach 20, if you are seeing me and you are 20 years, around 20 years, we are saying at that moment, most of your bones have already been turned into what? Into cartilage. So when this process usually is complete by the time somebody is reaching 20, 21 years there. Yeah, so we are saying, how will this process take place? So if we are forming a bone from cartilage, it means the shape of the bones, especially like the longer bones, for example, the bones in the arms, the bones within the legs, those longer bones, the shape they have is because of the shape of the cartilage from which they were what? From which they were formed. Mind you, I've told that the bones like the flat bones like the skull, the clavicle, and so on, those ones are formed from another type of ossification, which is intramembranous. So we are saying the cartilage, therefore, it is the model from which, is a cartilage, therefore, a model from which a bone is formed. So it means if I have my bone like this, actually, not a bone, if I have a cartilage, now because I'm saying we have a cartilage at first, then the cartilage is turning into a bone. So if I have a cartilage which is like this is the cartilage model I'm having. So it means it is this cartilage that is going to be turned into a bone. And when you form a bone, likewise the bone will also take up a same shape. So I am going to base my description on a cartilage. So I have a cartilage model which is like this. That's the cartilage model, because you have said the cartilage is what is going to form a bone. Now we are saying, for us to have endochondrial ossification begin, it begins that moment when a blood vessel, comes and penetrates, what? And comes and penetrates this cartilage model. I'm calling this one cartilage model. At this area which we are calling, which we previously called what? Shafty, or what we also called diaphysis. So when a blood vessel comes and penetrates this area, at this point here in the middle way, especially I'm now taking an example of longer bones. If it comes and penetrates at this point, that's the beginning point of this process known as endochondrial ossification. At that moment now, we say a bone, this cartilage has started now turning into what? Into a bone. And we are saying when this blood vessel comes and reaches here, I think I'm going to use a different ink to mean a blood vessel. Let me not use this blue marker here. If this blood vessel comes and reaches here and penetrates this area, what happens is, after penetrating, assume this is a blood vessel which has now penetrated here, this blood vessel will start immediately depositing, it will start now depositing some ions. Mind you, we have said that that cartilage does not have ions. So it is after the penetration of the blood vessel into this cartilage that now the blood vessel will start depositing ions. And when these ions are deposited within this area, within the shaft now, it means within this region here in the shaft, within this region of the shaft, we shall have bone formation starting. And we are saying it is from the entry of this blood vessel that the cells which were cartilage cells, which we are calling chondroblasts. The chondroblasts, when the blood vessel enters and starts depositing those ions, the chondroblasts at that moment are activated or are turned into another form, which is now osteoblasts. And then, of course, some of them are turned into some of the osteoblasts are turned into osteocytes, and others are turned into osteoclasts, as we have already seen previously in the previous episodes. And at the same time, we are saying when the blood vessel penetrates and enters into this region here, at that moment we are also saying that this, remember, if it was a cartilage, the membrane which was surrounding the cartilage, we were calling it do you still remember? It was called perichondrium. This was the membrane which was surrounding the cartilage, perichondrium. Now we are saying the moment a blood vessel enters and penetrates and is able to now start depositing, then the perichondrium that we had at first, which was the perichondrium at that moment, now turns into now the what was the membrane which was surrounding the bone. I'm sure you still remember if you have been following, and that is called periosteum. Yeah, periosteum, good. So at that moment, the perichondrium is turned into a periosteum. And therefore, we are also saying that when this blood vessel also penetrates, all these things are happening after the penetration of the blood vessel. When the blood vessel also penetrates, it also now starts it also forms what we call a collar of compact what? Of a compact bone, and this one is starting with the diaphysis. So at this point here, you start forming a compact bone. And we are saying these blood vessels, of course, not remain here. When they don't remain here, they keep on proliferating. They keep on moving towards the extreme end like that. And we are saying the more they keep on proliferating, or the more they keep on expanding to other different regions, is the more they keep on depositing. The more they keep on depositing calcium ions, phosphate ions, carbonate ions, and so on, to ensure that now the compact, the one which was a cartilage, turns into what? Turns into a bone. So we are saying that entry of blood vessels within the diaphysis stimulates the chondroblasts to turn into all these ones. It also causes at that moment we are saying that the perichondrium now is referred to as the periosteum. And we are saying that at that moment, at this point here, there is deposition. There is also deposition. The blood vessels start depositing of calcium phosphate, or calcium ion and phosphate ions, which make the area, which makes this region here to become hardened. And after it has become hardened, we are saying it forms what we call a collar of a compact bone within that region. And we are saying this collar of this compact bone which has been formed at the center here keeps on enlarging towards the extreme end. So the bone formation starts from the diaphysis, and it keeps on extending from the It extends from the what? It extends from the diaphysis, and it goes up to the it goes towards the other extreme end. That's at the epiphysis. Of course, this extreme end we have called them epiphysis. And then we are also saying that in some areas, in some organisms, for example, a mammal. I'm restricting myself on a mammal because we are mammals. We are mammals. So we are saying in an organism like in a mammal. By the way, the entry of this blood vessel at the diaphysis, this area, this starting area where we are having a deposition starting from, forms what we call the entry or the blood vessel penetration. Blood vessel penetration at the what? At the diaphysis. At the diaphysis forms what we call a primary ossification what? It forms what we call a primary ossification center. Ossification center. Why? Because that is like the beginning point where ossification starts from. So in a long bone, penetration starts at the center, and we are saying at the center there where the deposition of the ions are starting from, the turning of the osteoblasts into chondroblasts into osteoblasts and so on, where it is starting from, that one forms the primary ossification center. And now we are saying that in some mammals, not in some mammals, but in mammals, we are saying that we can have, because the bones are usually too long, we are saying that we can also have blood vessels penetrate this bone even at this extreme end, or at the extreme end known as at the epiphysis. We can have some blood vessels penetrate even at the what? At the extreme end, no, or at what I'm calling the epiphysis. Epiphysis can also come and penetrate from here. Now we are saying in cases where you have blood vessels also penetrate and penetrate at the extreme end. Now those ones, the blood vessels penetrating at the what? At the epiphysis. At epiphysis, now those ones now form what we call a secondary. They form what we call a secondary ossification. What? A secondary ossification center. That one forms the secondary ossification center at the what? At the epiphyses. So we are saying that in cases where you have long bones, like for example in mammals, we can have blood vessels penetrate not necessarily at the center. They can even penetrate as far at the extreme end to cause more ossification at the extreme end there. And we are saying in that case, this one will form what we call a secondary ossification center. Now we are saying what happens is that when these blood vessels penetrate here at the extreme end, ossification, these blood vessels do not proliferate up to the extreme end, and therefore this extreme end there is like a small layer which is not what? Which is not ossified, and that small layer which remains here, it means all these other parts here will undergo ossification, and then there will be a small layer at the extreme end where the blood vessel will not be able to reach, and that one will leave a small layer. That one will leave a thin layer. This will be leaving a thin layer of cartilage at that moment, and we are at that point there. And we are saying this small layer which is left here is also important. Why? Because it will help us in preventing friction, especially at areas where we have joints. For example, at different joints there, it also prevents friction, which is important in easy movement of bones at the joints. So that's why this one needs to be left there. So apart from us saying that the blood vessel will not be able to reach, may not reach there to cause ossification, we are saying it is important for us to have that cartilage layer, a small layer of cartilage at the extreme end, to ensure it prevents that friction. And we are also saying that at some cases where you find, for example, for the case of longer bones, or for mammals where you have longer bones, we are saying that sometimes you have these blood vessels come and stop somewhere like around there. Likewise, you have these blood vessels which are coming here and they stop somewhere like around there. Likewise, you also have these ones which have come from this extreme end at the second ossification center, come and reach somewhere like around there. You also have these ones also come and stop somewhere like around there. So it means at the end of the day, you find a small region between the epiphysis and diaphysis when it is remaining unossified. Why? Because the blood vessels from the center here, from the primary ossification center, and the blood vessels from the second ossification center have not been able to continue to elongate and reach that region. So this region here, it forms this part which is remaining here, especially in mammals when they are still young. This is called This one is called what we call epiphyseal plate. Epiphyseal plate. So this is a small region between the epiphysis and the diaphysis where blood vessels have not been able to really to seriously reach and cause what? And cause ossification, cause deposition of calcium ions, and what cause ossification. And therefore that part remains when it is more of unossified. Not we are calling it the epiphyseal plate. But I have said that one only happens when the organism is what? When the organism is still young. But we are saying in cases where you find that the organism has, as the mammal grows and becomes bigger, we are saying that the more as the mammal keeps on growing and becoming mature, these blood vessels also continue elongating, and at the end of the day, you find that this one, which was somehow big, which was a big region, which was also having cartilage here in the middle, it also, you find it keeps on reducing because the blood vessels keep on, nutrients keep on reaching this area, keep on diffusing up to this area, and also the blood vessels keep on proliferating, and they end up reaching here. So we are saying, in a very mature mammal, this epiphyseal plate keeps on reducing, and it almost disappears. And in that way, it leaves a small line, and that small line which is left just a small line, a thin line just in between. After these blood vessels have seriously enlarged and they are almost reaching each other, that small line which is just left there, especially in mature mammals, is what we call an epiphyseal. We call it an epiphyseal line. But this one comes later when an organism has matured. So that is it with the endochondrial ossification. Now, somebody might say, now, assume I am writing something like, for example, an essay in an exam and so on. What's the best way? How can I put all these words together? We have said endochondrial ossification. First of all, we define what is endochondrial ossification. Endochondrial ossification, we have said, is a process by which a bone is formed from cartilage. And we have the word chondro. We have endo. So it means a cartilage is used as a model for the formation of the bone. And therefore, it means the bone takes up the shape of the cartilage from which it is made. That's an introduction now. Then after now you come and say, this process, the process of endochondrial ossification starts, the starting point starts when, especially for the longer bone, starts when a blood vessel penetrates the cartilage model at the what? At the shaft. Or what you are also calling the diaphysis. So when the blood vessel penetrates the cartilage model at the shaft, what happens? At that moment, the blood vessels start depositing calcium ions, phosphate ions, or calcium phosphate, calcium carbonate ions, and that one makes that region at the diaphysis becoming hard, and that leads to the formation of a compact bone at the what? At the diaphysis. And we are also saying at that point, after the penetration of the blood vessel, the chondroblasts, which were the cells of the cartilage cells known as the chondroblasts, are turned into osteoblasts, osteocytes, and osteoclasts. Now, these osteoblasts and osteoblasts start depositing a bone matrix. Are you seeing how the bone is starting to be formed? These ones start depositing bone matrix, and then these ones, the osteoclasts, start also creating some ways through which blood vessels can also be able to penetrate. Remember, in the previous video, I told you that the osteoclasts, their work is to reabsorb the matrix to ensure they create ways through which blood vessels can further continue progressing within a bone to ensure that the whole of it is more hardened, and so on and so forth. Then we are also saying that after the penetration of the blood vessel, the perichondrium, at that moment, which was the membrane surrounding the cartilage model, is turned into periosteum. And we are saying this periosteum also is capable of producing also those bone cells. And we are saying that at the same time, we are saying that the blood vessel which has penetrated at the diaphysis, this blood vessel at the diaphysis forms what we call a primary ossification center. And we are saying these blood vessels do not remain at the center at the diaphysis, but they keep on proliferating, and as they move from the diaphysis up to the epiphysis. Then we have also said that for mammals with longer bones, we can also have secondary ossification center. We can have blood vessels penetrate these bones at the epiphysis. Now, when blood vessels penetrate the long bones at the epiphysis, then they form what we call secondary ossification center. And we are saying that after that we say that at the extreme end, the blood vessels not reach at the extreme end, hence they end up leaving a small layer of cartilage which plays the role in reducing what? In reducing friction. In reducing friction, especially at the joints. And we have said a small region exists between the diaphysis and epiphysis, which is not what? Which is not ossified. Why? Because of blood vessels from the diaphysis and one from the epiphysis not reaching that region. And that region which is left there, which is unossified, because of not being reached by the blood vessels, we are calling it an epiphyseal plate. However, we say that as mammals grow and mature and become more mature, these blood vessels also continue enlarging and elongating, and they end up also reaching that region, and therefore carrying ossification there, and also this part also ends up becoming ossified and also turns into cartilage. And then we have said, in that case, you find yourself that you just for as mature, when a mammal becomes more mature, this what was originally a big space known as the epiphyseal plate becomes reduced and it just remains as an epiphyseal line. I think we have learned something. Now, in the next episode, we are going to be looking at more. Please make sure you watch out for that. May God bless you.